Suppose we have a function f from set A to set B. Here set A is the domain of the function and set B is the codomain of the function. Now we have to find the total possible number of functions, number of one-one functions, number of onto functions, and number of one-one onto functions. For this, suppose number of elements in the set A, that is in domain, are m, and number of elements in the codomain B are n. So first we will find total number of functions possible from set A to set B. Total number of the functions will be n raised to the power m. This can be very easily verified that suppose this is the set A having the elements 1, 2 and so on up to m, and set B is having the element 1, 2 and up to n. There is a mapping from A to B, f. Here 1 may be mapped from 1 or 2 or 3 and so on up to, it may be also to n. That means one of the set A can be mapped to B in n ways. Similarly, second element 2 can also be mapped in n ways, and mth element can also be mapped with n ways. So total possible ways for mapping are n for first element, then n for second element, and it is for mth element. So it will be, these are the m times we have multiplied, therefore the total number of functions will be n raised to the power m. Second, we will find the number of one-one function, also known as injective functions. In the function from A to B, number of elements in set A, that is in domain, are m, and suppose number of elements in codomain B are n. So number of one-one functions will be equal to 0 if number of elements in codomain are less than the number of elements in domain, and it will be equal to factorial n divided by n minus m factorial if n is greater than equal to m. This can also be written as in the form of permutation, that is npm. It can be easily verified. Suppose this is the set A containing the number of elements 1, 2 and so on up to m, and set B has elements 1, 2 up to n. If element 1 is taken first, so there are n options for which it can be mapped. Therefore, first element can be mapped in n ways. After mapping this 1, the remaining options available for element 2 are n minus 1. So second element can be mapped in n minus 1 ways. Then third element can be mapped in 1 lesser, that is n minus 2 ways, and so on. And last element will be, that means mth element will be mapped with the codomain in n minus m minus 1 ways. So this can be written as n factorial divided by n minus m factorial. Third is, we have to find the number of onto functions. Onto functions are the function in which range equal to codomain. That means every element of the codomain are mapped with some element of the domain. So if we take the function from A to B and number of element in set A is m and number of element in set B is n, then number of onto function will be, in first case, if m is less than n, that means number of element in the domain are lesser, In that case, because element of domains are uniquely mapped with the codomain, then there will be some element remaining in the codomain which will not have the pre-image. Therefore, in case of m less than n, the number of the onto functions will be 0. And in second case, if m is greater than or equal to n, the number of onto functions will be summation r equal to 0 to n minus 1, and it is NCR. This is minus 1 raised to the power r and n minus r raised to the power m. So using this formula, we can find the number of onto functions in case when number of elements in the domain are more or equal than the number of elements in the codomain. And similar way, we can find the number of 1 onto functions, also known as the bijective functions. Suppose function is from a to b, where number of element in set A, that is in domain, is m, and number of element in the set B, that is the codomain, is n. In case m is not equal to n, if n is not equal to m, then function cannot be the 1 onto function. This implies that number of bijective functions or 1 onto functions will be equal to 0. In second case, if m is equal to n, in that case, number of bijective functions will be equal to m factorial. We take some examples. First example is, if set A contains 5 elements and set B contains 6 elements, then find the number of 1 onto functions. Here we have the mapping from A to B, and it is given that number of elements in A are 5 and number of elements in B are 6. This 5, suppose it is m, and this 6 is suppose n, because m is not equal to n. This implies that, as earlier stated, that number of 1 onto function will be equal to 0. Second example is, let function f a to b has number of element in A equal to m and number of element in set B equal to 2. Find total number of onto function. Given function is from A to B with number of elements in A equal to m and number of element in B, which we have shown with n, is equal to 2. So we have to find the number of onto functions. The formula of number of onto functions is equal to summation r equal to 0 to n minus 1 NCR minus 1 raised to power r n minus r raised to power m. Here n is equal to 2. So this formula comes summation r equal to 0, 2 minus 1, that means it is 1, then 2CR, then minus 1 raised to power r, and 2 minus r raised to power m. So it will be equal to, now we open this summation. First we put r equal to 0, so it is 2C0 minus 1 raised to power 0, 2 minus 0 raised to power m, plus then r equal to 1 minus 1 raised to power 1, and then 2 minus 1 raised to power m. Simplifying this 2C0, it is as the value 1, and 2C1, it has the value 2. So it is 1 into minus 1 raised to power 0, it is again 1, then 2 raised to power m, plus here it is 2 into minus 1 raised to power 1, that is it is minus 1, and 2 minus 1, it is 1, and 1 raised to power 1 power m, this is also 1. So we will have 2 raised to the power m minus 2. This is the answer. Here we can see that if we consider the total number of functions, this is total number of functions which is n raised to the power m, if n is the number of element in codomain and m is the number of element in domain. And here we have subtracted 2 because is codomain having the 2 elements. In that case, we have to eliminate 2 cases where the all element of the domain are mapped with the single element or the first element of the codomain, and in second case all elements are mapped with the second element of the codomain. So this is the answer. Next example is, let function f a to b has number of element in a equal to 3 and number of element in b equal to 4. Find the total number of injective functions, that is 1 functions. Given function a to b has number of element in domain is equal to 3, which was represented by m, and number of element in codomain b is equal to 4 and represented by n. Because n is greater than m, so number of injective functions or 1 functions will be equal to, it is npm, or we can write it as factorial n divided by n minus m factorial. Substituting the value here, n is 4, so it is 4 factorial divided by 4 minus 3 factorial. 4 factorial is 4 factorial divided by 4 minus 3, that is 1 factorial. 4 factorial can be written as 4 into 3 into 2 into 1, and 1 factorial is 1. That means it is 24. So total number of 1 functions are 24 if domain has 3 elements and codomain has 4 elements.